In this video, we're going to talk about how you can combine capacitors that are connected in either series or parallel. And really, before we even work out the details here, the way to remember it is it's just the reverse of resistors. So for resistors, when they're in series, you add them, and when they are in parallel, you have to do the more complicated formula. For this, it's the exact reverse. So when you have capacitors that are in series, you have to use the more complicated formula, which is just saying take the individual capacitances, take the reciprocals of them, add them all up, and take the final reciprocal of that answer, and that will get you your equivalent capacitance. So again, the rule for parallel resistors is the same as the rule for capacitors in series. And there is the shortcut where if you just have two of them, C1, C2, you can turn that into a single capacitor whose value is C1 times C2 over C1 plus C2. On the other hand, when you have capacitors that are in parallel, this follows the easier rule where all you have to do to find the equivalent capacitance is add them up. So you don't have to do the more complicated rule. It's the simpler rule for resistors where you just add them all up. And now that we have these two rules, we can take a random circuit here with capacitors and go ahead and combine it. Start by seeing that we have a 60 and a 120 that are in series here. So by doing our rule here, right, we have 60 times 120 over 60 plus 120. It's going to work out to be 4 there. On the other hand, I also have a 50 and a 70 in parallel, so you're going to add those up. So if I go ahead and perform those two tasks here, the 50 and 70 makes it into a 120 microfarads. The 60 and 120 made it into a 4 microfarad. We still have the 21 here. Then we can do the 20 and the 4 that are in parallel. We're going to add those up here, making 24. And then lastly, we go ahead and do our series rule, which is 120 times 24 over 120 plus 24. And it's going to be a total of 20 microfarads. And we found the equivalent capacitance. So combining capacitors is really no more challenging than combining resistors. It's just the rules are flipped here. The only really thing you don't get to use is the Y delta formulas, but we can still go ahead and use these two rules here to simplify pretty much any capacitor network we need to deal with.